Hello students, today we are going to discuss how bubble sort microcontroller. We will simulate using type. Before discussing the actual program in the microcontroller, we first need to know how bubble sort works. So we briefly see how bubble sort works. Then we'll do the programming. So suppose we are given 5 numbers 18, 2, 10, 31 and 16. These are the 5 numbers we are given and we want to sort them in descending order. That is, the largest number will be first, then it will be sorted, like the smallest number will be on the left hand side, right hand side, and in the left hand side there will be the largest number. So in this way we need to sort them. So how we can do this? There are multiple algorithms or the ways how we can sort a range of series of number. Here we are particularly discussing how bubble sort works. This is called bubble sort, what the algorithm we are going to discuss. So what we do in the algorithm, we simply compare the pairwise the first two number. Suppose this number is pointed by A register, this number is pointed by B register, then what we will do, we will simply compare A and B and check. If A is greater than B, then do nothing. We show it by cross. Do nothing. Leave it as it is. 18, 2. No change. Next again check second number and third number. 2 and 10. Now 2 become A, 10 become B. Again we are comparing. If A greater than B, no, it is not greater than B. If not greater than B, then swap. Swap means this place will have this value 10 and this place will have the 2 value. So in the next step we see 18 is as it is, this 2 becomes the third element and 10 becomes the second element. This is swapping. This swapping is done. Now again in the next iteration we check. Now 2 becomes A and 31 becomes B. Again we check if A greater than B. No, A is less than B. Then we need to swap. Again we swap. 31 comes here, this 31 comes here, and this 2 comes here. So we have done swapping. Okay, now we have 18, 10, 31 and 2. Now again we check. Now 2 becomes A and 16 becomes B, because we are shifting one by one every time. Now we check 2 and 16. A greater than B? No. So again swap. So 16 comes here and 2 goes there. Now we see that there were 5 elements. So we need to do this comparison how many times? N minus 1, that is 4 times. 5 minus 1. So we'll do this comparison 4 times. 1 time, 2, 3 and 4 times. Now what we have in the last position, we see that the smallest number reaches the last position. Like a bubble comes out from the bottom of the water to the surface. Similarly, once we do this pairwise comparison, we see that the smallest number reaches to the end. So smallest number reaches to the end. So this is the first iteration. So each comparison becomes the inner loop, and the whole thing, the first, that becomes the outer loop. That is the first iteration. Inside the first iteration we have 4 such comparisons. So comparisons will be done inside the inner loop, and this whole thing will be the first iteration. In the second iteration we now have, this is the situation, 18, 10, 31, 16, 2. Now we don't need to consider this 2 because this is already in the its correct position. There is the smallest number in the right side. So what we have to do, we need to sort this 4 number. So this time we need to do 3 comparison, because total there will be 4 number, 18, 10, 31 and 16. 2 is done. So for 4 number we need to do n minus 1, there is 3 comparison. So we compare 18 and 10, we see A is greater than B, so do nothing, 18, 10 as it is. Now next time this 10 and 31, so 10 becomes A, in this case 10 becomes A and 31 is B. So we compare A, B. We see this A is not greater than B, A is less than B. So we have to do swapping. So swapping is done. Here 31 and this 10 becomes in the third position. So what we get? 18, 31, 10. Now there is 16. So again 10 and 16. Now 10 becomes A and 16 becomes B. So we do if A greater than B, no, false, A is less than B, so we have to do swapping. So 16 comes here and 10 comes here. Now we see after 3 comparison in the second iteration of outer loop, we see that 10 and 2 reaches its own position because 2 is the smallest number, 10 is the second smallest number. So in the third iteration of the outer loop, we only have these 3 numbers that need sorting because these 2 are already sorted. So in this time we will do only 2 comparison because there are 3 numbers, so we need to do n-1 comparison, only 2 comparison. In the first comparison, this becomes A, first variable, and this becomes B, the second variable. Now we check if A greater than B, no, false, then do the swapping. So it is the swapping, 31 comes here, 18 goes there. So now the number becomes 31, 18, 16, 10, 2. Now in the second 18 and 16 we need to check 18 is A and 16 is B. If A greater than B, yes, A greater than B because 18 is A and 16 is B. So A greater than B, no swapping required. Keep it as it is, 18 and 16. Now we see these 3 are actually already sorted. Actually everything is sorted, but officially algorithm wise this may not have been sorted, but in this case it is sorted. So this part is sorted, guaranteed. So next time we only need to do one comparison. So R1 is 1. So do comparison 31 and 18. 31 is A and 18 is B. Now we check if A greater than B, yes, A greater than B, so no swapping, keep it as it is, 31, 18. So processing done, we have this number. It is completely sorted in descending order, largest first and smallest last. So this is the algorithm. Now what we will do, we will implement this same thing in our microcontroller code and we see one by one mapping, so we will understand the code very easily. What we are doing in the first 5-6 lines, we are storing the number, that is this number 18 to 10 30, these are decimal numbers, so we will be storing in their hexadecimal form. So these are the number we will be storing in 30H, 31, 32, this 34H in the memory, internal RAM. Once we store this number, what we need the first need the R0 register. So what we need actually, we need one register, that is R1, that will contain the number of elements. There are 5 elements. How many number to sort? That will be stored in R1. So here R1 is 4 because initially we will store 5, then during processing we need to do the n-1. So we do DEC R1, that is decrease R1 by 1. So R1 becomes 4. And what else we need? We need the location of the first element. So that will be pointed by R0. You see, move R0 comma hash 30H. That is, now R0 points to the very first element address R0. So R0 becomes the address of the first element, that is 30H. Points to the first element. Now what we need to do, we need to store this first number in A and second number in B. So how we do? In the outer loop, move A comma R1, that is R1 has 4, so then move R2 comma A. Now we give this value to R2, R1 value, we store R1 value into R2, so R2 also become 4 and R0 38, that is done. Then what we will do, in every step we'll now in the inner loop we will do this comparisons. So coming to the inner loop, move A comma at the rate R0. So now this first value goes to first value 30H pointed by R0, this value is stored in accumulator. So move A comma R0. Now accumulator has the first element, first value 18. Then INC R0. R0 is now pointing to the second element, increment by 1, so it is pointing to 2. Now move B comma R0. Now B has the second value, this 2 goes to B. Now what we do, we need to compare CJNE A comma B, compare. That means compare and jump if not equal. So compare A and B, jump if not equal. So we know this A and B is not equal, so jump to compare. Here is the compare level. So we jump to this point, JNC skip swap. What is JNC? JNC means jump on no carry. If there is no carry, then go to skip swap. So now we need to see if when carry occurs, if the first number is larger than the second, then there will be no carry. 18 minus 2, no carry. But if A is less than B, then there will be carry. So in this case, when 18 and 2 is compared, there will not be any carry. So jump on no carry. So there is no carry, so jump to skip swap. So we jump to skip swap this person. What this line does, this reduces the value of R2. R2 is the number of element, now 4, so it reduces from 4 to 3 and go to inner loop. So inner loop will continue. Inner loop how many times continue? Next time again it will become 2, then it will become 1, then it will become 0. So it will be running 4 times R2 inner loop. Why 4 times? Because we need to do 4 comparison. One comparison is done. Now we'll go to second comparison. Then in the second time what will happen, R0 is pointing to 2, so now in the second time move A comma R0. Now A will contain the value 2, then we increase the R0. Now R0 will point to 10, and then we move B comma R0, so B will contain 10. Then again we compare A and B. This time this CJNE, it will be saying that go to compare, because A and B are not equal. Come to compare, then JNC skip swap. Here as A is 2, B is 10, so there will be 2 minus 10, so there will be carry, because smaller number minus larger number, so there will be carry. So in this case this skip swap will not occur because there will be carry, so it will go to the next line. In the next line what we do, move at that R0 comma A. So we need to swap. So what we are doing, we are storing the value of accumulator into R0 location. So R0 location is the second location now. This location, 2 location is R0. So what we are doing, we are simply storing the accumulator value. Accumulator contains 2. This 2 comes to R0 location, this portion. Then what we do, we need to point to this location. So R0 will be decremented. So DEC R0, this DEC R0. Now R0 points to this location, second location. This location becomes R0. Now what we need to do, we need to store this 10 value here. Initially both becomes 2. Now we need to bring the 10 here. How can we bring? The 10 is there in the B register, so we need to move the value from B to R0. So we do move R0 comma B at the R0 comma B. So the value from B, this 10 value comes to R0. So swapping is done. Increment R0. Again we point R0 to the second number, because always that is the case. The R0 becomes the second, points to the second number in the pair. So now R0 points to 2. Now we come to DJ and JR2, because the second comparison is done. Now we reduce the R0 value again 1, it becomes 2. Then again go to inner loop, and the next time again we will do comparison 2 and 31. We do the swapping, reduce the R0, again we do the swapping 2 and 16, reduce the R0, R0 becomes 0, so we are out of inner loop. Now we go to DJ and R1. So R1 value is now reduced by 1, from 4 to R0 becomes, R1 becomes 3. In the next time again inner loop starts. In the inner loop again we do the comparison how many times? This time 3 times. 1 time, 2 time and 3 time. Then it is out of the, again out of inner loop. Again R1 will be reduced to 2. Again we do this 2 comparison. Then R1 will be 1 comparison. Then R1 will be 0. We will going out from this loop and we go to done. This is the whole process how it is done. Now we see that we will do the build and build target, and then we will see the debug mode, that is it really doing what it is supposed to do. So now go to debug mode, and in the debug mode we need to open the memory. Now we have opened D:0x30, that is the data memory, internal RAM memory. We have opened the 30x, because this 30h location we will be storing the values and do the sorting in this location only. So let's run first 5 lines. So first 5 line we get the values loaded in the 30 to 34h. Now we start the program where we will be doing the sorting. So what we are supposed to do, after some step we see that we will check the key points. First iteration it will be inner loop, nothing will be done. In the second iteration of the inner loop, 2 and 10 will be swapped. So this second and third value will be swapped. First time nothing will be done. So if we continue on the first inner loop, there will be nothing, because here it will go to simply skip swap, because nothing to swap. 18 and 2, 18 is greater than 2, so there will be nothing. So there will be nothing, it is directly going to DJNJ. Now in the next time we will see some swapping. Next time it will be this is the swapping code, so this swapping will be done. We will see second and third number will get swapped. So we will see this 2 and 0a, this will be swapped. So now both become 2. So the value from A register goes to this place. Now we need to put the value from B register to this place. So from A register value goes to this third place. Now we need to do B register contain the value of this earlier value 10, that has to come here. So if we check, B register has the value 0a, 0xa. This value will come to this position 02. So if we run the next line, then DEC R0, so it will be now pointed to this location, and now the move is occurring. So now from B register 0 value comes here. This swapping is done. Now again in the next loop again we will see one more swapping. This swapping is done, 2 and 10. In the next time we will see again swapping 2 and 31. There is 2 and 1f, there will be again swapping. 1f will come to third position, 2 will go there. If we go on in the inner loop, this swapping is going on. So this swapping is done. You see 1f is here and 02 is here. Again in the next loop, 2 and 10 will be swapped. 2 will be in the last position. So if we continue in the next loop, now the swapping code. So both become 2, and then this 10 comes here. So the first round is over. So our R2 value is 1. Now R2 will become 0 and go to R2 become 0 and it go to R1. R1 will be reduced by 1. Now R1 will become 3. So R1 become 3 means we are now, this part is done, and now we are here. This is the starting. So the data is like this. 2 is at the end, so 2 is sorted. Now this 3 to be sorted, this 4 to be sorted. So there will be only 3 comparison, and for the first time nothing will happen. Second iteration there will be a swap. Third iteration then again there will be a swap. So if we see, first time nothing will occur. In the second iteration there will be a swap. This is the swap is occurring. So both become A. Now this has become 1f. So the swapping has been done. So next time again there will be one swapping, A and 10. There will be swapping. 10 means 16 and A means 10. So this there will be swapping. So next time we see there will be both become 0A. Now 10 comes here. So this swapping is done. Now we see these two are 16 and 2 is sorted. These two are sorted. So next again now, so this part is done. This part is done. Now we will be doing this. R1 is 2 and we will be doing only 2 comparisons. So this part is now, we are there in the second part. So this, in this time only one swapping will occur. Swapping is done. This swapping, second time no swapping. So this swapping is done. Now again this time no swapping. No swapping directly from here to here, no swapping. So R2 will become 0. After the execution of this, R2 becomes 0. We go to R1. R1 is 2. So R1 is 2. R1 will become 1. R1 is 2. As soon as we execute one line, R1 will become 1. So this is the last iteration, this last time. There will be no swapping, and that is the final result. So this time there will be no swapping directly from here to here, no swapping. These 3-4 lines are the swapping lines. So comes to here. So then there will be R1 become 0 now, and everything will be R1 0. So it is out of loop. So done. So these numbers are already sorted. 1F, that is the 31, this is 18, this is 16, and this is 10, and this is 2. It is completely sorted, as we see, 31, 18, 16, 10, and 2. So hope I am able to make you understand how it works, and the code I will be providing the code in the description, so you can try and run and try to understand every line. You can try with more numbers by changing this R1 value.